Remember the first time you saw that iconic blaster shootout in Star Wars? The screen lit up with streaks of red and blue, and suddenly, the idea of a weapon made of pure light didn't seem so far-fetched. For many of us, it was pure movie magic. Stormtroopers missing every shot, Han Solo firing back with his signature swagger, and those unforgettable blaster battles echoing through the galaxy. Star Wars didn't just entertain us, it sparked our imaginations. Suddenly, every flashlight became a blaster, every cardboard tube a lightsaber. Kids and adults alike dreamed of wielding these futuristic weapons, even if it was just in the backyard or at a fan convention. We all wanted one, even if it was just a flashlight in our hands. The fantasy was so vivid it felt almost real. For decades, laser weapons were just sci-fi fantasy, a cool what-if that seemed impossible. They were the stuff of comic books, movie screens, and wild speculation always just out of reach. But now, fiction is colliding with reality. In secretive military labs and high-tech test ranges, engineers are building and testing real laser weapons. There are no colorful bolts or dramatic sound effects, just invisible beams of energy, silently disabling drones and electronics in the blink of an eye. The US Navy is already installing laser cannons on destroyers, ready to defend against threats at sea. The Army is rolling out laser-equipped vehicles, preparing for a future where energy weapons are as common as traditional guns. The impossible is becoming possible. What once belonged to the realm of science fiction is now a matter of national security and technological innovation. Today, headlines are filled with stories of directed energy weapons being integrated into defense systems. The world is watching as these once imaginary technologies become part of our everyday reality. The leap from movie prop to battlefield tech is happening now, faster than anyone could have predicted. Engineers are taking inspiration from science fiction and turning it into science fact. The question isn't just whether we can build laser weapons, but how they'll change everything we know about warfare and defense. Imagine a world where ammunition is measured in kilowatts, not bullets. Where a beam of light can travel at the speed of, well, light, striking targets instantly with pinpoint accuracy. What happens when a beam of light replaces a bullet? How does warfare change when your ammo is electricity, and your weapon never runs out as long as you have power? We're standing at the edge of a new era, where science fiction becomes science fact. And the tools of tomorrow are being built today. So let's dive into the real story of laser weapons, tracing their journey from the galaxy far, far away to the battlefields of tomorrow, and discover how our wildest dreams are shaping the future of defense. Let's break it down. A laser weapon is a directed energy weapon, meaning it fires energy, not bullets. Instead of launching projectiles, it projects a focused, high-energy beam of light. Think of it as a super-powered magnifying glass but with surgical precision. The goal? Deliver enough thermal energy to heat, melt, or vaporize a target, what's called a thermal kill. Lasers can burn through drone wings, fry electronics, or detonate warheads from a distance. Power matters. Lower power lasers take out small drones, higher power ones can stop missiles or boats. It's not about explosions, it's about speed, precision, and disabling threats instantly. As long as you have electricity, you have ammo. In a world of sledgehammers, laser weapons are the scalpel. How do you weaponize light? It's all about physics. Laser stands for light amplification by stimulated emission of radiation. Unlike a light bulb's chaotic glow, a laser is a perfectly organized beam. It starts with a gain medium, crystal, gas, or fiber optic, energized by a power source. Excited atoms release photons, which trigger more atoms to emit identical photons, a chain reaction of perfectly synchronized light. Place this medium between two mirrors, and photons bounce back and forth, amplifying the beam. One mirror lets a fraction escape as a single, coherent laser beam. The result, a focused, powerful stream of energy, all photons marching in lockstep. That's the science behind turning light into a weapon. It's not magic, it's precision engineering, and it's changing the battlefield. This isn't science fiction anymore. Laser weapons are here, and they're transforming the way militaries think about defense and offense. What once seemed like a distant dream from futuristic movies is now a reality, deployed on ships, vehicles, and in the hands of soldiers. The US Navy's HELIOS system, a 60-plus kilowatt laser, is already installed on destroyers to defend against drones and boats. This high-energy laser can track, target, and disable threats in seconds, providing a silent, invisible shield for naval fleets. It's a game-changer for ship defense, offering precision and speed that traditional weapons can't match. Lockheed Martin has delivered a 300-kilowatt laser, powerful enough to intercept cruise missiles and potentially neutralize even more advanced threats in the future. This leap in power means lasers are no longer just for small drones. They're now a real answer to larger, faster, and more dangerous targets. These systems are changing naval tactics, offering new ways to defend ships and project power at sea. With lasers, ships can respond instantly to incoming threats, conserving ammunition and reducing the risk of collateral damage. The Army's DEM Charade program mounts 50-kilowatt lasers on Stryker vehicles for mobile air defense. These vehicles can move with frontline troops, shooting down drones and rockets before they become a danger, and providing a flexible shield wherever it's needed most. These aren't prototypes, they're being field tested by soldiers right now, in real-world conditions. Troops are learning how to use lasers in combat scenarios, integrating them into their daily operations and tactics. Defense giants like Raytheon and Northrop Grumman are racing to build more powerful, efficient and compact lasers. Their engineers are pushing the limits of what's possible, working to shrink these systems so they can fit on more platforms and be deployed anywhere. The arms race isn't about bigger missiles anymore, it's about better lasers. The focus is shifting to speed, accuracy, and the ability to fire again and again without running out of ammunition. From sea to land, directed energy weapons are moving from the lab to the battlefield. Militaries around the world are watching closely, eager to see how these new tools will shape the future of warfare. The era of laser defense has arrived, marking a turning point in military technology. With each successful test and deployment, lasers are proving they're ready for real combat. And it's just the beginning. As technology advances, expect to see even more powerful, precise, and versatile laser weapons shaping the battlefields of tomorrow. So, where's your laser rifle? The answer? We're not there yet. The biggest hurdle is power. High-energy lasers need massive amounts of electricity. Vehicle-mounted systems use generators. Shrinking that into a rifle-sized battery isn't possible with today's tech. Heat is another problem. Lasers generate a lot of waste heat and cooling systems are bulky. Without cooling, a handheld laser would overheat after one shot. The atmosphere also weakens laser beams. Rain, fog, and dust scatter the energy. Adaptive optics help, but they're complex and expensive. Finally, cost. These systems are intricate and pricey, with prototypes costing millions. Until we solve power, heat, weather, and cost, laser rifles will stay in the realm of sci-fi. But the race is on. What's next? If we crack power and cooling, handheld blasters could become reality. Imagine breakthroughs in energy storage, compact power cells, or even microfusion. Once that's solved, cooling tech will be the next big leap. But the future isn't just handheld. Think fighter jets with laser pods, virtually unlimited ammo, speed of light defense. In space, lasers are even more effective. No atmosphere to weaken the beam. Satellites could use lasers for defense, debris removal, or even missile shields. The Star Wars concept is inching closer to reality. Lasers will get more powerful, smaller, and more versatile, used for defense, crowd control, or even data transmission. The future of lasers isn't just about weapons, it's about redefining power and strategy. The sky's no longer the limit. So, are laser weapons science fiction or reality? The answer, both. The flashy, explosive blasters of Star Wars are still fiction. Real lasers don't fire visible bolts. Handheld blasters remain a dream, blocked by power and heat challenges. But the core idea, a weapon that uses directed energy to disable or destroy, is real. The US Navy and Army are fielding laser weapons right now. Defense contractors are building systems with power levels once thought impossible. These weapons are silent, invisible, and used for defense, but they're undeniably real. The gap between sci-fi and reality is closing fast. We're living through the transition, turning childhood fantasies into world-changing tech. The blaster from the movies isn't real, but the invisible beam that stops a missile is. Science fiction inspired it, engineering made it fact. Laser weapons are no longer a distant dream. They're shaping the future of defense. What once seemed like science fiction is now a reality, with advanced laser systems being tested and deployed in real-world scenarios. These innovations are changing the way we think about security, protection, and the very nature of conflict. This isn't just for generals, it's a conversation for all of us. The impact of these technologies will ripple through our communities, affecting not only military strategy but also our daily lives and the values we hold as a society. New technology brings new responsibilities. As we push the boundaries of what's possible, we must also consider the consequences and ensure we use these tools wisely. We must ask, how should these tools be used? Who decides when and where they are deployed? These are questions that demand thoughtful debate and careful consideration. What are the ethical implications? Stay curious. Stay informed. Engage in discussions about the moral dilemmas and societal impacts that come with such powerful advancements. Understand the difference between Hollywood and reality. While movies may dramatize laser technology, the real-world applications are complex, requiring rigorous testing, regulation, and oversight. Ask tough questions about global stability and rules of engagement. How will these weapons affect international relations, treaties, and the balance of power? For young engineers and scientists, this is your call to action. Solve the challenges of power, cooling, and optics. Your creativity and expertise will shape the next generation of directed energy systems. The future of directed energy will be built in your labs and imaginations. Every breakthrough starts with a question, a sketch, or a bold idea. Technology is a tool. Its impact depends on how we use it. We must prioritize safety, responsibility, and the greater good as we move forward. As we turn science fiction into reality, let's do it with wisdom and foresight. Let's ensure that our progress benefits everyone and safeguards our shared future. The future is in our hands. Let's build it right together with vision, responsibility, and hope.